So if you were at a dinner party and somebody said, yeah, I study insect pee, the room would go silent and everyone would turn to the person and say, why? And that's what we're going to talk about today, but a little more than that. Saad Bhamla is a scientist that gave a really interesting TED Talk about how bugs pee, insects. Like the glassy-winged sharpshooter has this like butt flicker, and little balls of pee get shot into the air really quickly. And that's different than how we pee, because we have streams of fluid, right? And he looks at the difference of that, and he kind of takes us on this little journey. The biggest part of Saad's exploration in science has to do with nurturing our curiosity. Because once you get, especially young minds, around the fascination of science, it becomes the thing they want to do a lot. Because it's surprising, it's playful, and when you put things under a microscope, it's just fascinating. So I'm really happy to just indulge in this rich conversation of how we approach science and how we discover things under microscopes, but also under our beds. Like, how can we bring the enthusiasm that Saad has for science into our own lives, that we discover things all the time. Welcome to Swell, Saad. I wanted to just tell you first off that the website that you bring us into is just beautiful. And sometimes science websites are more about abstracts and things people discover, but yours is like a wonderland. And it's really, it's very immersive. And I love the call out you have, which is let's discover together. And that's something you're basically all about, whether it's someone you're going to work with or someone who's going to come in here and just look at all the publications and all the research you've done. Thank you so much for also just being one of those teachers that infuses people with capacity and agency, because I think sometimes we learn and it becomes like this block of knowledge, but I think your style is really about changing us as researchers ourselves. Like, scientists always get the title of this person studies this, and that means you're a student of life always. And sometimes we forget that studying for scientists goes on, and we should also adopt that behavior. Can you talk a little bit about a day in the life of your work so that we could just drop in today? Like, how do you structure your days, and how do you decide what to study, and how do you know when the studying of something is over? And also, due to the subject matter of your work, anybody listening, please feel free to leave a question, because this is really fun, and he's such a fun presenter, and I think we can really enjoy the back and forth here. So welcome, Saad, and welcome anybody else who wants to pop in.
Okay, I did not know that studying insect pee was a thing, but now I am weirdly fascinated. I know that with humans, you can tell in general about humans things about their pee, but also then very specifically about this specific human and their health. Does this also apply to insects? Are there general things that you're learning about insects, and then is there specific information you're learning about this specific insect that you're studying? And if so, like what kinds of things are you learning? I don't even know where to begin because this is not even on my radar of possible things that people would study. And so and how in the world did you get into it? What started this path? Oh, and what makes it so exciting to continue? I mean, I'm fascinated, but this is just my first exposure to the idea. But for you to continue doing this, I'm, as I said, strangely curious.
Hi, Deborah. Thank you for inviting me to Swell. It's a nifty app, and this is my first time participating in this, and thanks for the kind words. Let's see, I'll try to answer all of your questions and the wonderful kind of tee up that you did. Regarding the website, I think it was my mission to create a website as a scientist for myself and my team for our lab that communicated our excitement and how much we enjoy studying organisms and understanding their physics. And you're right. Growing up, I always saw academic websites and was appalled by how minimalistic and bare minimum and kind of generic they were, and they wouldn't communicate why us as scientists actually do science. It's because there's a thrill of discovery. It's being a detective, a explorer, kind of being at the vanguard of generating new knowledge and solving puzzles, but that never came through. And oftentimes, scientific papers can be intimidating for a young researcher who wants to get into the field, or a person who is removed a couple of steps from the scientific process. So, in any case, we team tagged with Kika from Impact Media Lab, who's just her and her team are just brilliant artists and help scientists like us, kind of create a visual medium to communicate who we are and why we do what we do. And so the website is just a delight. I'm just proud of it and what we have there. Regarding how a day in the life looks like, we've got a lab full of different types of organisms we study, all the way from field work. So we do field work in the Amazon rainforest and Brunei now, and Zoo Atlanta and Tennessee Zoo. So it's just a non-stop backed action of trying to understand how a large variety of organisms just do, from thing critters that can walk on the surface of water, how they can do it, why they do it, how we could understand these principles mathematically through robotic models. We have projects on trying to understand how teams of sled dogs can go for hundreds of miles in Antarctica. And yeah, how spiders can launch themselves. So it just, when I realized that I could have basically a career in studying living systems and trying to understand their physics, it's just this Alice in Wonderland kind of thing. You just keep going down these rabbit holes, and just one thing leads to another. Also, it's great to have a great, wonderful team, brilliant team of scientists that you work with, because they kind of lead the work, and then we have back and forth, and we kind of just keep every day is just full with meetings, new discoveries, and coming up with new hypotheses, new ideas. And That's just how it goes. It's just a non-stop filled adventure every day. Insect Pea is just amazing. We stumble into it. I observed them in our backyards in Atlanta, and now it's just given us this new, fresh perspective into studying the other business part of insects that were overlooked. And so many questions over there that we're just exploring, from mosquitoes to sharpshooters to cicadas, to nymphs that are underground. Yeah. But anyways, thanks. Happy to be here on Swell, and I'll log back in again if to answer other questions.
Hey, it's Theo. Thank you so much for posting this. And one thing I just got to get out of the way real quick is that Insect P is probably a really good name for a punk band. Because, punk bands have, in some cases, all these very mashed up names. And Insect P, yeah, even the punks in the crowd probably wouldn't see that one coming. But I'm definitely going to be following this, and I love the fact that, I think in many ways, and I don't think people realize this, to study other species is to kind of study at least the world we inhabit. And I think as humans, or the term, and I think it's term only, the dominant species on this planet, we tend, I think we've reached a point in, unfortunately, many ways where we don't choose to understand the world around us, and that there are things that exist outside of cities and buildings and things of that nature, and that there is just so much life, above, ground, the sky, the ocean, and, to just have an understanding of that, I think is so important in so many ways. And I think, outside of scientists themselves or people in the scientific community, I don't know how much people really connect to that anymore. And it's kind of unfortunate because, it's not just us on this planet. We're not alone. And we tend to think, we're the sole purpose for it all. And it's not the case. It really is just a matter of knowing and observing, what other species, insects, what have you, what they're like, how they function. And it's always fascinated me because to learn something about another species is, like I said, it's to kind of have an understanding of the world around you, or at least it should. So this is absolutely fascinating. I'm looking forward to hearing so much more on this, and thank you for posting this. And as always, I hope to talk to you real soon.
I'm loving this conversation as well, and thank you all for popping in. Saad, it's great to hear your voice, your enthusiasm, your playfulness. It's infectious. And I know anybody listening who's even thinking about going into the field of science would appreciate this invitation that you're giving just by virtue of your fascination and your belief in the work you do. There's a gentleman that I just finished interviewing who on Swell here, who is talking about sea slugs. That's his work, and he focuses on how they photosynthesize to make food in their bodies, and it's fascinating. And we were talking about how there doesn't always have to be an end to the means, but the means itself is the journey, and the process of learning expands how we see other things, and I think that's part of the justification for me of why we need to spend all our good government dollars and private dollars on research for things that seem tangential to the infrastructure of life, keeping the roads and the lights on and stuff. But the ability to go inside a world that's right next to us, right under us, right around us, and try to understand it more it's so thrilling and so invigorating. Can you talk about, I guess, the fascination you have with mechanisms inside bodies that aren't ours? I'm just wondering, when you create robotics to mimic that, is that a path towards application in some other realm? Like when you look at how the insect pees and you see that brilliant lever system and that friction and all that stuff that happens with that flip and that ball that goes in the air, and you create a mechanized situation in a robotic space, do you look for, now let's use this for this? Or is it just a way to understand it? And have you ever used something differently because you've mechanized or created a robot simulation of an insect, and then you say, let's try this? Like, I know that when spiders throw their web, there's something there that we learn from. So can you give us an example of how a real life world mimics what we learned from insects?
All right. Okay. Oh, wow. That's a really, really hard question that you're asking about how real life mimics insects and how we can learn. I'll try to kind of help share how I approach it, and I'll kind of give you varying levels of answers that might perhaps be unsatisfactory at different levels, but hopefully it'll paint a picture. So I think this classic example, and when people think about this, is this concept of biomimicry or bioinspiration, where we might consider Velcro as inspired from, plants that might attach to things to hitch a ride, or thinking about how ants navigate a cluttered rainforest and how that might inspire swarm robotics, or, how we coordinate drones, etc., etc. And I think that's all valid, and that's there. But I want to offer you a slightly different perspective, at least how I approach this. So the first is this lens at which we can look at the biological world, at these organisms. A naive appreciation of them is that they might be messy, right? Biology looks very messy. It all looks complicated. There's a lot of chemistry going on, biology going on, thermodynamics, mathematics. And my approach to this is to apply this lens of engineering and physics, and all of these systems look just like you describe as mechanical systems. And I think that just helps you appreciate how phenomenally ordered, and there is this physics of life in there. So in the insect P, we discovered that they were doing super propulsion and obeying kind of these remarkable laws of physics that govern life, right? Like the surface tension of water, oscillator dynamics, and energy transfer and power transfer. And that's just so elegant, because now you help appreciate that it's not just random, it's not just chaotic, it's actually is leveraging clever physics principle. And that just gives me kind of a high, because it just helps you appreciate how tuned a system might be and gives you another lens to appreciate life. So that's one. The second part, and this is a colleague of mine that uses this, so I can kind of steal his comment. And this is what naturally we like to think: why do you study bugs and use taxpayer money? And what's an application of this? And I always struggle with this. And so when he's a mathematician who kind of looks at toys, and he said, when I describe my work to kids, it makes them happy. And I think it's a great application. And I think that's another way to appreciate this, because whenever we make these comics and share this science, it also helps people appreciate and makes them, look at the natural world through this new lens. It's a superpower, right? To be able to look at a flying thing or a walking thing and realize, oh, there's beautiful engineering and sophisticated mechanics going on, and you appreciate the beauty more than just kind of try to swat at a fly and not appreciate what complicated evasive maneuvers it's doing, and how does it sense your hand, and how can it see photons of light and dodge it, and how could we make, think about kind of the fluid dynamics and aerodynamics of it. So that's kind of that aspect. And kind of the last approach, I'll kind of share how this kind of informs kind of futuristic things we may do, and bring about these robotic things, because we were able to advance fields of science and knowledge and codify it into principles of physics and engineering, because we kind of blend things of understanding how nature works, but also look at it in these simpler systems, man-made systems. So that's the approach we take, because we know more about thermodynamics by thinking about steam engines and flying and swimming, both because we are still trying to understand, how birds work and how fish work, but also because we apply them in engineered systems, so we can kind of push the limits of our own understanding in more rigorous ways. So that's kind of our approach. That helps. We build these mathematical models and robots because we are able to codify kind of the laws of science in a much more quantitative and robust way. Anyways, it's all just the joy of many different facets of this. So thanks for asking that cool question.
One never needs to defend their joy, and I think that's really the theme for artists as well. Michael and I talked about that with studying sea slugs and photosynthesis. And the wonder you bring to this, and the sort of, you can get so myopic, and that's why I was asking, like, when does this ripple out to, like, the world? But I think we need to keep going as seekers and as discoverers and as educators who stimulate the minds of people who will see this, and then you never know, in 10 years they might say, wow, this reminds me of this bug who pees, and I learned how they did it, and I want to try it here. And it's so interesting. I don't know how familiar you are with Burning Man and all the machines that people create to kind of go in the desert and be wild. And sometimes they just look like huge insects doing crazy things, mechanical and metal and fabrics, and it's just amazing. And some of the work I was looking at on your website just reminds me of just the beauty and the chaos. And we shouldn't be afraid of the chaos. We shouldn't be afraid of the unknown, and that's part of your work. I have one final question, and then I just want to thank you for being here, and I'm hopeful that you can share some of your discoveries here when you have a chance. Just open up a swell and snap a photo and say, look at what I found. It would be such an honor to have you here sharing with us. My final question to you has to do with, I guess, the scope of your work with regard to funding. I'm always fascinated by this, and I hope it's not too pedestrian a question, but how do you fund your lab? And is it a cycle of funding, or do you get like 3-year grants? And do you ever work with commercial entities, or is it always just grant-based? Just curious to let us know how you're thriving, and so we understand that part of your world as well. Thank you so, so much. This has been a thrill.